In this example, we are calculating the magnetic flux. And so remember, the magnetic flux is, the symbol is phi. And to calculate the magnetic flux, we just take the area, so the area of like this square, and we want the area times the B field. And when we're thinking about flux, we want to think that it's the area times the B field times the dot product of the area and the B field. But just remember, I think one of the most confusing things about that is if we think about the dot product. So if we think about the equation phi is equal to B dotted with A, right, where A and B are vectors. Well, if we have an area, like in this case, we have the area of this square, the area vector is really the area times the normal to the surface. And the normal to the surface is always perpendicular to the surface. So really what we're doing is we're saying B times it's B and the perpendicular component of A. Right, so we're really saying that it's the B field, and in all these cases, the B field is coming directly out of the page, so it's exactly in line with the normal. But if we were to draw this and we drew like a square like this is my square, and the normal vector points perpendicular to the surface. That's my normal vector. So when I say the area vector, that's equal to the magnitude of the area and in the direction of the normal. And so that's directly away from the surface. But we can calculate flux, right? The magnetic flux using this formula. So that's what we're going to do for these examples. So let's look at this example first, right? So we're going to say the flux is equal to B perpendicular to A. So if we look at this one, we have B is equal to 1. So for this one, our flux is going to be equal to B is equal to 1 times the area, and it's just 2 times 2. So in this case, our flux is going to equal 4. In this case, we have our flux is going to equal to the B, which is 2, times the area, which is going to be, the area is just the side, so 1 times 1. So flux here is going to equal 2. Go to the next slide. In this case, our flux is going to equal B, which is 1, times the area, which is 1 times 2 for a rectangle. So our phi is equal to 2. And here we're going to have flux is equal to, our B is equal to 2 times the area, which is 2 times 1. So our flux is going to equal 4. And for this last one, they're trying to be tricky. So we're going to have, we only are going to calculate the flux in the part of the rectangle where there's actually field. So we're going to not worry about this part. And we're just going to think about the bottom part. So that B is going to equal 2 times the area. And so this is going to be 1 times 1. So 1 times 1. Right, so phi is going to equal 2. So if we go back, here, we know that this one, our flux is 4. This one, our flux is 2. This one, our flux is 2. This one, our flux is 4. And this one is our flux is 2. So we would say that the flux is like flux of 1 is equal to the flux of 4, because they're both 4. But that's greater than the flux of 2. But then the flux of 2 is equal to the flux of 3 and is equal to the flux of 5. So 1 and 4 are equal. So phi 1 equals phi 4. And then these 1 and 4 are greater than 2, 3, and 5. And so let's just check. I think we have a summary slide right here. Yeah, so we phi 1 and phi 4 are equal, and then they're greater than the other 3, but they're equal, and then just the how we calculated them is right there.